Well, here we are. We are back at it again with radian measure. This is lesson 2. I know it says 6.3. That's just the old school way that I used to do it. Anyhow, here we are. Got a couple goals. So kind of a long lesson. It's going to be a 2-parter. And we're going to figure out what are radians, how can I convert from degrees to radians and radians to degrees. And then we're going to be doing a lot of finding angles and exact values using radians. And this is sort of the big topic on the exam. So another way to measure rotations of an angle is to use something called a radian. So what exactly is a radian? Well, here it is. You heard it here first. The official definition: when the terminal arm rotates around a circle the same distance as the radius of the arm, then the angle created is equal to the measure of 1 radian. So if you think of this as theta, this is the radius, and this is S, which is the curve length that this thing travels along. So say you got your radial arm and you're pushing it. When S and R are equal, that is 1 radian. There you have it. So we get this new little formula, S equals theta R. So that will tell you the length of the rotation along that arc length. And that is, 1 radian is when R and S are the same. All right. So what is a radian? Well, what is the formula for the circumference of a circle? Well, that's going to be 2 pi r. And there you have it. This can be thought of as 2 pi radians. Now, you might be saying, why? Well, remember, on the unit circle, r is equal to 1. So if you go to 2 pi r, plug in r equal 1, then you get that the circumference is going to be 2 pi radians. This is the equivalent to 360 degrees because it is a circle, okay? Therefore, 180 degrees, if you take your 2 pi and you divide by 2, right? So 2 pi is 360 degrees. So divide by 2, and you get 180. Divide by 2, and you get pi. If you divide by 2 again, and divide by 2 again, 90 degrees is equal to pi over 2 radians. For this unit of measurement, we leave the pi in there, okay? So it's a precise way of measuring angles. So you're going to be getting used to leaving pi in all of your answers. Okay, so how many degrees is 1 radian? Well, let's start with this assumption here that 360 degrees equals 2 pi r. And if we let r equal be 1, because we're on the unit circle, then really, as we saw in the last slide, 360 degrees is equal to 2 pi. So if we're going to figure out, well, how much is 1 radian, we'll just divide both sides by 2 pi. So if we divide both sides by 2 pi, we're going to have 360 over 2 pi equals 2 pi over 2 pi. So this gives you 1 radian. And over here, if you divide them both by 2, you're going to get 180 over pi. So now we know that 1 radian is 180 over pi degrees. Divide both sides by 360 to find the radian equivalent for 1 degree. So again, you're starting here at 360 degrees equals 2 pi, but this time divide both sides by 360 degrees. So you'll get 1 degree equals, again, divide them both by 2 and you get pi over 180. So now we have a conversion to go from one way to the other way. The way that I used to remember like which one's which is like if you're trying to get to radians, the pi is in the top. Right? So remember, radians have to do with pi, with a circle. So I just used to remember, okay, so it's like, it has something to do with 180 and pi. If we're going from degrees to radians, I'm going to multiply by pi over 180. And if I'm going from radians to degrees, I need to get rid of the pi, so I'm going to divide it out. It worked for me. Maybe it worked for you too. All right, so every radian is equivalent to that, like we said before. So we have a formula, and we can do a couple of questions, really basic questions here. So change the following radian measures into degrees. So what we're going to do is we're going to multiply by 180 over pi, and as you'll see, the pi's will cancel out, and then you can go 6 into 180, and you get, well, that's 30 degrees. Same thing here, just multiply by 180 over pi. The pi's will cancel, the 5 can go with the 180, multiply by 4. A little bit trickier. You're going to get 144 degrees. Now here, remember, radians, it can just be a number like this, right? So there doesn't have to be a pi in it. So 3.5 radians, what we got to do is multiply by 180 over pi. So in this case, we're going to have a pi in our answer. Actually, no, the answer I gave was just, I typed it in on my calculator, and I got 201 degrees. So there you have it. let's do the opposite. So every degree has a radian equivalent of pi over 180. So we can convert degrees to radians by using that formula. So we're just going to multiply by pi over 180. So you know, how many times was that, like a quarter? Maybe I can flip the page. Yes, it is a quarter. So you're going to get pi over 4. This one here, again, multiplied like that. And let's see what we get. You can divide by 10 and then divide by 2. You get 8 pi over 9. Of course, you can pause the video. Feel free to work these out. Now, this one here, part C, should be no surprise. So maybe just before I do this, come up with an idea of what you think the answer is going to be. And pause the video. And here it is, right? 180 goes into 360 twice. So 2 times pi gives you 2 pi. So that's not a surprise. Right? We know that 360 degrees is equal to 2 pi. That was the first thing that we started with. All right. Well, you can have more. We can do one more. Why not? So again, if you want to pause the video, take a peek at what you get before I do it. I mean, obviously, we can cancel a 0, and then we can divide them both by 2. So you get 25 pi over 9. Done. Woo! Okay, here it is, all nicely summarized for you. So if you have a circle with radius r, a central angle of 1 radian is subtended by an arc with a length of r. Ooh, that sounds ugly, right? But that was that first picture we had when s and r were the same. So that was 1 radian where they traveled the same length. A central angle of theta radians is subtended by an arc with length theta r, or conversely the length of an arc. Yeah, basically this is that whole s equal theta r formula. It comes up on the exam, so you can actually figure out the length of this arc by using that formula there. Of course, this does need to be in radians. And here you have it, 1 radian is that many degrees, and 1 degree is that many radians. So there you have it, perfect, everything nicely summarized. And let's do a couple more examples here. There we go. Yeah, no, I don't know if we need to do all of these examples, but let's just, you know, we basically, these are all going to be try it yourselves. They're very similar to the ones that we just did. So try it on your own. I will give you some answers. So pause the video at this point, try them out, and I'll just write the answers out here. So for A, you're going to get 4.45 radians, right? Like for this one, you're going to take the 255 degrees multiplied by your conversion factor to get to radians, and you're going to get that answer. For part B, you know, they're giving us, what are they giving us? Yeah, we'll sketch the angle too, so let's see. So that's what they give us. We'll convert it, right? So we'll go 180 divided by pi. When you do that, you're going to get negative 128.6 degrees. Now, if you were to sketch it, so for the sketch, well, this is negative, so we're going to be traveling this direction. Remember, this is 0 degrees, this is negative 90, and that's negative 180. So all you got to do for your sketch is just make sure that you're somewhere in between here. They are getting picky about being close to the center point. So like if you go 90 plus negative 45, that would be exactly negative 135. I'm pretty close to that, so you know, it wouldn't be unreasonable for me to draw it sort of in the center. So you draw it like that, and then you got to label it and draw the arrow, which is indicating which direction you're rotating. So there's C, or there's B rather. Part C, I'm just going to give you an answer. You're going to be multiplying by 180 over pi, and the value they gave us was negative 2.85, so multiply, you're going to get negative 472.7 degrees. Done! Woo! Alright. Ooh, that's ugly. I'll make sure that's not included in the notes. Same thing with that. Here, this is what I was trying to get to. So in grade 11, you guys learned that cosine, sine, and tangent values for 30, 45, 60, 90 degree positions around the unit circle. So in grade 12 pre-calc, what usually ends up being pretty useful is that you memorize those values on the unit circle. So actually, this is the one I handed out to you guys in grade 11. So you'll notice that we got the degree measurements, okay? But now we also have the radian measurements. In grade 12, we basically focus on radians, although occasionally they will ask you questions that are in degrees. Now I'm going to show you a really quick and easy way to memorize this. So It involves using reference angles, and what I want to point out is that if you do my way, you only need to memorize quadrant 1 values. Okay, so I'm going to point something out right now. So for pi over 6 radians or 30 degrees, this is the coordinate for x and for y, right? Remember that sine theta is just equal to y on the unit circle. The reason is because that was our formula from yesterday, but r is equal to 1, right? So what ends up happening is when we divide by 1, it goes away, you just have sine theta equals y. So that's why every y value is the corresponding sine theta value, and every x value is the corresponding cos theta value. Check this out. This is 30-degree reference angle. Over here at 5 pi over 6 degrees, or 150 degrees, that is also a 30-degree reference angle. And look at the coordinate. It's the same coordinate, square root of 3 over 2.5, square root of 3 over 2.5. What's the difference? The sign. Now, what do we know about our x values in quadrant 2? The x values are negative, okay? So if you can memorize pi over 6, then you know that in quadrant 2, 5 pi over 6 is going to have the same exact coordinate, but with a negative sign because x values are negative. And then you might be asking me, but hey, how do I know this is 5 pi over 6? Well, just use your knowledge of fractions. So we know that this is 0 degrees, 90 degrees, and this is 180 degrees, or pi. Now, what's another way to write pi? It'd be 6 pi over 6, okay? So if you went back pi over 6, that would be 5 pi over 6, okay? So using that method, you can actually memorize the whole unit circle just by memorizing quadrant 1. Okay, and that's what I recommend you do. You've got to put in the time to memorize it, or at least know enough that you can sketch it out. That's what I used to do, and use your knowledge of those points, okay? So a lot of the questions we're going to do have to do with this, and it's handy that you memorize it. So I usually start off sort of rusty when the term starts off, and my memory gets refreshed pretty quickly. So let's just do some questions from yesterday, but now we're doing them sort of in radians. So what is a positive coterminal angle between 0 and 2 pi? That would be like saying between 0 and 360, right? In grade 11. Of this. Now, yesterday we learned that to get a coterminal angle, we add or subtract 360. In radians, that's 2 pi. Okay, so if I want a positive coterminal angle, I'm going to add 2 pi. But I need to get a common denominator here, right? So I'm going to recopy that. I'm going to multiply this by 6 over 6. And there it is. So now I can go, okay, well that would be 7 pi over 6. Okay, and is that landing in my interval here? Well, 2 pi is something over 6 would be 12 pi over 6, so yeah, I am landing in that interval. Now this one is outside of my interval, right? Because 2 pi is 12 pi over 6, and I need to be in this interval. This is 13 pi, what was it, 13 pi? Yeah, so this is 26 pi over 6. That's way out of my interval. Okay, so I'm going to have to subtract 2 pi, get a common denominator. So 2 pi will be 6 pi over 3. Okay, do that. That's going to give me 7 pi over 3. If it's over 3, this is just slightly bigger than 2 pi, right? 2 pi is, I don't know, are we good? No, yes. Yeah, 2 pi, if it's over 3, is going to be 6 pi over 3. That's 2 pi, so I'm just a little bit bigger. So I'm going to subtract 2 pi again. So I'm going to subtract 6 pi over 3, and I get pi over 3. Yay! Sorry, that was a little messy, but there you have it. End of the day. I'm tired, that's my excuse. Now, these questions are saying, what is the sine value of this? Now, there's 2 ways you can do this. You can figure out the reference angle for this. So if you went and sketched this out on your unit circle, okay, this would be 12 pi over 6, or 2 pi here. So if you were here, you would need to ask yourself, so I rotated 11 pi over 6, what would that angle be? Well, how much further do you need to travel to get to 12 pi over 6? It would be pi over 6. That would be the reference angle, okay? Now, the reference angle for pi over 6, or a 30-degree angle, what is that xy coordinate? This is the part you need to memorize. So if you go back, that's the xy coordinate. Now the sine value is the y value, okay? So the y value is -1/2. Why is it negative? Over here it's positive. Well, remember, all we did is we found the reference angle and we went back to quadrant 1. We need to consider, 11 pi over 6 is in quadrant 4 where the y values are negative, hence -1/2. That is tricky. We have lots of these in the homework because you'll need lots of practice on them, okay? This one is kind of even trickier because it's a negative angle, and negative angles kind of not my favorite. So you have a couple options here. Again, I think the sketch really helps. Okay, so if you're going -pi/4, that means that you're rotating this way. Okay, -pi/4. The reference angle is already pi/4. Okay, so if you go to a unit circle and you look up the pi/4 value, okay, which is 45 degrees right in the middle, that's the value that has √2 over √2 for both. Okay, for both x and y, okay? Now you just need to consider for the sine value in quadrant 4, it's negative. So you're gonna get negative √2 over 2. Wonderful. This is not easy, people. Some cosine values. Now, this is bigger than 2 pi, right? 2 pi, if it's over 6, is 12 pi over 6. That's 2 pi, right? I'm over here at 17 pi over 6. If I'm gonna find a reference angle, I need to figure out, well, what is this on the unit circle from 0 to 2 pi? So let's go ahead and subtract 12 pi over 6. And we're like, oh, that's 5 pi over 6. You have options, right? You can find the reference angle. We know that theta r is pi over 6. This is the example I did. Okay, so if you go back, okay, so if you memorize all of them, and you're just like, hey, I memorized 5 pi over 6, the x value is -√3 over 2. That's okay. I hate memorizing stuff. I'd rather understand how it works. So if you do it my way, once you figure out that it's 5 pi over 6, you go draw your sketch and you're like, oh, how much further to get the reference angle? So it'd be pi over 6. And then I'm like, okay, pi over 6, that's the one I memorized. It's √3 over 2, but I'm in quadrant 2, so it's -√3 over 2. Well, there you have it. So for this one, if you go figure out the cos value, so if you were to go cos 17 pi over 6, you get -√3 over 2. If you were to type that in on your calculator, you would get the decimal equivalent of that. Again, this one here, so 2 pi is 4 pi over 2. This is bigger than 2 pi, so I'm going to subtract 2 pi. So I can figure out what the angle is. It's pi over 2. Now this is the one that's right at 90 degrees. Pi over 2 is right at the top. You're on the unit circle. Okay, so this is the point 0 for x and 1 for y. Cosine is x. So if you go cos of 5 pi over 2, try it on your calculator. Make sure you're in radians though. Okay, make sure you're in radians. If you type that in, you will get 0. All right, now the tangent values, those ones suck so much because tangent is the ratio of y over x. So a little bit trickier to get. Now this one here is indeed something that you can figure out. Okay, so basically they're asking us what is tan of 4 pi over 3. So I'm between 0 and 2 pi. If you learn the pi by 4s, it's pi over 4, and then this one over here is what? Go back and look. You know, like definitely refer back to this often until you have it memorized. 3 pi over 4. Now we're looking for 4 pi over 3. Is that one that we can do? Yeah. 4 pi over 3. Well, you know, sure, why not? Where is it? Right. Pi over 3, 2 pi over 3, 4 pi over 3. Boom! There it is. So if you want to do all that memorization, you can memorize it and be like, oh, it's y over x, so you'd have to do that ratio. You're gonna get pi over 3. You're gonna get just square root 3. So let me show you here. Where did it go? I like to find the reference angle, personally. Okay, so for that one there, this would be 3 pi over 3 or 180 degrees. So I know it's over here. So I rotate all the way around and I say, oh, that's 4 pi over 3. which would mean my reference angle is pi over 3. Okay, I recommend that in quadrant 1 you actually memorize your tangent values just in quadrant 1. Okay, they're sort of easy to remember, so it goes pi over 6, pi over 4, and pi over 3. And the corresponding tangent values go like this. It's 1 over square root 3, 1 square root 3. Okay, so for a reference angle of pi over 3, the tangent value is square root 3. Now we're in quadrant 3 where y and x are both negative, so overall a negative divided by a negative is positive, and that's how you get that one. This one here is very interesting. So here's pi over 2. Now this is negative, so you're rotating counterclockwise, so that's negative pi over 2. This is the point 0 for x, negative 1 for y. So remember, tan, it's y over x. Well, my x value is 0. So if I go negative 1 divided by 0, I actually get undefined. That's a very tricky one. Watch out, because they do like tossing those ones in on the exam. That was a lot of work. We can do a bit more practice. I threw this down here for reference for this one. Okay, so tangent values are the ones I hate the most. So again, if I look at this one, you got to establish, is it between 0 and 2 pi? If it's not, find a reference angle that is. Okay, so if it's over 3, right, then 2 pi would be what? It'd be 6 pi over 3. That's 2 pi. This is, well, smaller. It's on the negative side. So I'm going to add 6 pi over 3 to find a coterminal angle. And I get that this is the equivalent of negative pi over 3. Negative pi over 3 I can do. Okay, so it's simply the mirror image of this one, but down here. So it's going to be down here. You go negative pi over 3 units. And we know, we memorize that for tangent, for pi over 3, it is the square root of 3. You just need to figure out the sign. Now in quadrant 4, x is positive, y is negative, so overall that will be negative. Boom! Now, these ones are particularly hard. So yeah, they can bring in the non-primary trig ratio. So for cosecant, just remember, in question B, we do not know, we don't know this one, right? So it says estimated or give it to the nearest hundred. This is one that would come up on the calculator part of the test. But the question is, what do you plug in? Well, remember, cosecant and sine are inverses of each other. So if I do sine, if I do the inverse of this, it would be equivalent. So I would go to my calculator and type that in, and I do believe we get 1.28. So try it out. I'm going to add in maybe an extra one here, because I see it pop up on the exam. So let's try this one. So try, what is secant of pi over 3? Give it a shot. See if you can use the definition. Just remember, here's my hint, that secant theta is 1 over cos theta. So what is theta? That's theta, okay? So if I want to know the answer to secant pi over 3, I can use a formula 1 over cos pi over 3. Now this one is one that you memorize. The cosine value for the pi over 3 is 1/2 and square root 3 over 2, right? Here it is. Whoop, I didn't scroll up high enough. Hooray, De Niro. You're killing it, right? So the x value is 1/2. So I just go and plug in and say, well, this is 1/2. Okay, so 1 divided by 1/2 is, drum roll, anybody? Anybody? Hello? Oh yeah, nobody's here. It's Corona time. The answer is 2, right? There you have it. That's the end of day 1. So this is actually a very long lesson, so I'm going to break it up into 2 pieces. So we're going to stop right there. There's 2 more questions, then we'll stop. My notes are all yes. Okay, so we'll do another one. Let's do this one. It is a try it yourself. You should be able to do it on your own by now. So pause the video, but I'll do it. I'll do it right now. So this is just slightly bigger than 2 pi. So what I like to do is figure out what's the coterminal angle. So I'm going to add 2 pi. And I'm going to say, oh, this is negative pi over 6. So here's pi over 6, right? But the negative one would mean that you're rotating this way, right? And it is the sine value, which is the y value, so it's going to be a half. But in quadrant 4, it's negative, so you get negative a half. Now this one is a tricky one. Remember, cotangent theta is 1 over tan theta. Okay, so first of all, oh, it's asking me to the nearest hundredth, right? So you don't have this button on your calculator. So what you're going to do is you're going to figure out what 1 over tan of 12 pi over 5 is. You're going to plug that in on your calculator. Okay, it says to the nearest hundredth. In that case, you get 0.33. So there it is. Thanks for joining us. This is going to be the day 2 material. Okay, so you can try the first half of your homework. And tomorrow we will do all this stuff, which is way more interesting, I promise. See you next time. Bye-bye.